And, oh, by the way, I'm Jane Walpole, I'm the Vice President. This is for everybody. Charles wants everybody's name.
Yeah.
He would like everybody's name and your number to see who was here tonight.
Right.
And this,
And how to contact.
you want to start off? Okay, there's two brochures in the back. One is from Tualatin. Talks all about the path that they have and the work that they've done. The mammoths and it's really good pamphlet. And this one's from the Park Service, and it's their pamphlet for this area, for the lower Columbia Ice Age flood, which is us. So they're back on this back, they're free, and they're back on this table.
Hi there, everybody. Hi. Whoa. I got my handicap here. Yeah, it's a good handicap. So, my name is Charles Hall, and I'm the president of this Ice Age Floods chapter. We were founded in 2004 on my birthday, February the 17th, 2004. And so I was proud of that. I went to the market, got myself a cupcake, put a candle in it, lit the candle, then blew it out. So tonight we have a marvelous speaker. And it's Vic, I'm going to tell you a little bit here. So Dr. Vic Baker is our speaker tonight, and he's a very, very distinguished gentleman. He has a bachelor's in science and geology from Rensselaer Polytechnic Institute, 1967, and a PhD in geology at the University of California, 1971. God, I don't know, I'm University of California. He's University of Colorado. I'm sorry, but I apologize. Okay, Colorado, please forgive me, sir. He's on the faculty. His faculty positions following his finishing his college work was University of Texas at Austin, 1971 to 81, 10 years, advanced up the ranks to the rank of full professor in geology. University of Arizona, 1981, and he moved to that, where he is presently one of the first full professor. He was first full professor, and then one of the very first University of Arizona Regent professors. So Vic is Regent Professor of Geology at the University of Arizona. And in 1996, and through 2004, he was the head of hydrology and water resources, now hydrology and atmospheric sciences at the University of Arizona, Regents Professor. He's a very prolific author. 1,100 scientific contributions, 450 research articles and chapters, 560 abstracts and short research reports, plus 35 extended technical reports, 52 encyclopedia articles, 39 published books, reviews, among many other things. Your probably, this is all listed in the constant contact with you folks. I hope you all received. If you didn't, I want to ask you a good job of handling this. This research concerns paleoflood hydrology, a field that he defined in the 1970s and the 1980s. It also concerns flood geomorphology. Did I pronounce that right? Close enough. Channels, valleys, and geomorphic features on Mars and Venus. Also, catastrophic Pleistocene megaflooding in the northeastern United States, that'd be us, and megaflooding coming out of Montana, and Central Asia. History, philosophy of Earth, and planetary sciences, and the interface of environmental science and public policy. His work on megafloods has been featured in multiple television documentaries for PBS, BBC, and the National Geographic Discovery and History channels, including the 2005 Nova production, Mystery of the Megaflood, and the 2017 Nova production, Violent Earth, and the episode was Killer Floods. His memberships and honors are extensive. I did not list all this, but his memberships and leadership, Geologic Society of America, President, 1995. American Association for the Advancement of Science, section on Geology and Geography, the chair in 1992 to 93, and again the chair from 2008 to 2009. Internationally, and the next one is International Union for Quaternary Research Commission on Global Continental Paleohydrology. President, 1995, 1999. And Lower Columbia chapter. He's been a member here since 2005, and we were founded in 2004, and so to date, and certainly a loyal and founding member. Thank you, Bill. He has received many honors and fellowships in his long and distinguished geologic career, including Fulbright Hayes Senior Research Fellowship, 1979, 1990, 1980. And so, without saying anything for him, because he has a wonderful story to tell tonight, I love it. So I present Dr. Victor Baker, Victor R. Baker, Regents Professor at the University of Arizona, for his talk tonight. My personal interactions, and the name of the talk is My Personal Interactions with J. Harlen Bretz and His Outrageous Geological Hypothesis for the Origin of Channel Scatterings. Okay?
So after that introduction, I had to have a very modest title.
Oh, you did? What'd you do?
It actually is cut off.
Oh.
The title.
Oh, okay.
We had to switch equipment. So that happens when you produce a slide for one computer and your slides get a little mixed up. But I think they're going to mostly be there. So this talk is going to be a bit different than the ones I usually do. Usually I talk about the science of the mega flooding, both in the channeled scabland and in other parts of the universe. It used to be just the channeled scabland, but it's gotten to be a much bigger thing, and we'll get into that. This is going to be more personal in regard to J. Harlen Bretz, who I had the good fortune to meet. That's Bretz on the left. With time, we get to look more like one another. We looked a bit different in the past. By the way, Bretz didn't like this particular picture. It was taken by his daughter, Rhoda. And I'll show a picture later because she took a different one, and his preferred picture. Okay, you have to wait for that one. I'm going to talk a lot about Bretz, but this has to involve me too. And so we'll both fit in the story. Now, most of you know something about the channeled scabland and the controversy that arose over it. But I'll just give a little background. The whole context of this wasn't apparent when Bretz started to study it. So this slide, a map of the northwestern U.S., you see the state boundaries, is really kind of a big picture of mega flooding associated with the terminal phase of the last ice age. So these would be features that were on the landscape 16,000, 18,000 years ago. The blue areas are covered by ice, and you see prominently Puget Sound, which you're familiar with maps, was called under ice. In fact, the shape of it reflects the lobe of ice. All that ice extending into Canada was part of the Cordilleran ice sheet, giant ice sheet covering most of British Columbia, extending up into the Yukon. And the orange areas were impacted by cataclysmic flooding in this time frame. The CS is the region that is kind of the main context, the Channel Scabland. And you see the relationship to the glaciers. This flooding here was the Bonneville flooding that came out of Lake Bonneville in Utah, and they all converge on the Columbia River. And of course, we're here in the Portland Basin, where floodwater went into the Willamette, and also out onto the floor of the Pacific Ocean. None of that big picture wasn't present for Bretz, but the important aspects of the Bretz story are the Columbia Gorge and the Channel Scabland, and other features will fit into this. Now, here's a little more close detail on the relationship of the Channel Scabland to Glacial Lake Missoula, Glacial Lake Columbia, various lobes of the ice. You notice the pattern of this, although it is not something, although you think of it as fluvial processes, flooding, it doesn't look anything like a river. There are rivers here. One of the biggest rivers in North America is the Columbia that comes out of British Columbia, makes a big bite around the Scabland area, goes through Wallowa Gap and out through the Columbia Gorge. This whole area in the light bluish color, separate from the area not flooded, which is shown in brown, is a very complex of channels. Bretz gave it the name Channeled Scabland. And the reason he called it Scabland is what the topography looks like there in that aerial view from Bruce Bjornstad, who, if you go on his website, you can get wonderful aerial views of the region. So those of you who are familiar with the area have probably been to Dry Falls, which is it would have been a waterfall at low flow. Dry Falls is actually part of an immense cataract complex. So the picture here is what you would view from the visitor center looking at these 400-foot high cliffs. Here's the visitor center, and you'd be looking in this little area there. This is the Dry Falls Cataract Complex. It is several big drops, big gash, an entire area of grooved basalt surface. This kind of surface is called scabland, and it is on an immense scale. If you drive through this, you see at the human scale, but you don't see at the scale of what the flood was doing. So this black and white is a satellite picture, a satellite called Landsat. And those of you who have been to that country know there are a lot of wheat fields, and they have different levels of crop development. And this is the checkerboard pattern of the wheat fields. The scabland is the dark zone. And close up, this is a typical scabland. It consists of basins and buttes in between. This little white line is a dirt road. So these things are immense. They sometimes call them potholes, but potholes you think of at a human scale in the bottom of a river. So the biggest of these is like a football field across. So these are incredibly big. Everything is big. That Dry Falls is smaller than the tip of my finger here. It is just part of this immense complex. So part of this is how it is really big and how Bretz figured that out. Here's a more modern sort of depiction of how the floodwater moved across this area. The dry falls area is near that sea, that's Cooley City, and that's where it is located in this big complex. An area very important to how Bretz got into the problem is this place called Potholes Cooley. And you notice that it's actually a cataract like Dry Falls, but it has no, whereas Dry Falls has the Grand Coulee, this immense gash leading toward it, this is a large basin. It was a desert basin when Bretz came in. It had sand dunes across it. There was a little creek called Crab Creek that was way over on the other side and came down this way and then went out over here. So this is an immense cataract complex. What is it doing there in the middle of a desert? It's called an anomaly. And Bretz, some people will scientifically encounter that and they think, oh, that's weird, and then go on and do something else. Bretz had a true scientific attitude. He was bothered by it and wanted to figure it out. So who was this guy, J. Harlen Bretz? That wasn't his name, by the way. He was born Harley Bretz. That was his name, his birth name, on his birth certificate. He had to put it on his license. He was born in Michigan. He had kind of fundamentalist religion parents, which made him an atheist for the rest of his life. He wanted to be an astronomer. And he went to Albion College, a private school in Michigan. And he started to take some astronomy classes. He had built his own telescope. He'd done the whole amateur thing with astronomy, looking at stars and planets and all of that sort of thing. But in the astronomy class, he found that there was a problem. There was this thing called mathematics. And it was then that he realized that when he was a little boy, he fell out of bed, he hit the side of his head, the side that did mathematics. And so, scientifically, he wasn't going to be an astronomer. And so he kind of was left with biology, so he was interested in that. He used to collect reptiles and scare the girls in his class with them. And then there was geology. Eventually geology won because he started teaching high school biology in Michigan, but he got a better deal out in Seattle, and kind of the geology found him in the Puget lowland of Seattle, and he was very much an outdoors person. He took groups of Boy Scouts and others all over Puget Sound. He got interested in all the features that he saw on the landscape. And he got so into it that he was going to the university, talking to professors. He wound up using that material for a dissertation at the University of Chicago, which had really the best program in glacial geology in the country. He got it in 1913. He got an assistant professor job at University of Washington. He lasted there 1 year. He wasn't very happy with his colleagues. I like to tell my friends at University of Washington about that. And he left to go back to Chicago for a lower level position. He went back to be an instructor. But he was teaching field courses, and he took advanced graduate students out to the Columbia River Gorge. And so he started doing his field research there. Here's some early pictures of the field group, University of Chicago grad students. You notice the professor's got the hat, the pipe. The grad students all have the hat, the pipes. I didn't get the bottom. They have the high boots, and You can see them up here. They're all kind of mimicking the professor. But he didn't want them to mimic him in his ideas. He had a very distinctive teaching style, which I'll come back to later. But in the Columbia Gorge, his first work, he published a paper on it, and he once told me if there was one paper that he could ever have destroyed and erased from human memory, it would be that one, because it was completely wrong. He viewed the Columbia Gorge as having been flooded by water, but the water came from the sea, not from up, so it was the wrong direction. And there's another whole story to that, but he eventually got onto the right track for his investigation, and it's kind of like a crime scene investigation. You follow the clues, you follow the evidence, and he had been impressed by a topographic map showing this feature here called the Potholes Cataract that I mentioned earlier. That it's not a desert now. All that green stuff is irrigation water. It's put onto sand with big center pivot irrigators, and all the fertilizer and everything's put in there, and we get tremendous crops. But it was all desert when Bretz came here. And it's a giant cataract complex. You see the topographic map over there. So how could this come about? Bretz did the field work starting in 1922. He then, he went out. This is the field operation. You see the enclosed car there. That's a four-cylinder Dodge. And then he had the Model T. You see the students all piled into that. There's the Model T down at the left. Of course, Bretz is sitting there. The students are contemplating the difficulties that one encountered in the field in those days. And they're, going over the Scabland topography. So I can't really tell the whole story of this. This is kind of background. One of his last papers on it in 1969, he reflected back on the essence of what he was doing. And typical in geology, it's represented by a map. And this was a map he made before aerial photographs. So you saw those maps of the Scabland area that I had produced with satellite pictures and the like. And this is what he made driving around the country, walking across it with his students. He was able to build the complete picture. And it was a picture of what had been stream valleys that filled with so much water that they spilled from one valley into the next valley. Now, the valleys weren't big enough to carry the flow of water. So this was completely outrageous in terms of geology, because the geologists of his day were very much into the idea that the Earth developed over millions and millions of years, and it was the long-term action, the slow action of rivers, of ice, of other processes that over that time could create big river valleys. This was called uniformitarianism. And Bretz was saying, this is created by an immense cataclysmic flood, so much so that the valleys are irrelevant. It just flows across the whole landscape. And the reaction to this was intense. He described this in a paper I'll show a little bit later. He said, over the 9 years where he started publishing papers on the Scablands, which began 100 years ago. First papers, 1923. This is the 100-year anniversary of Bretz's putting into scientific print the outrageous geological hypothesis for the origin of the Channel Scabland. So here's how he describes it. Many voices were raised in expostulation. He loved to throw those words out there. The general tenor was, this heresy must be gently but firmly stamped out. Scientists try to be very polite. we're gentle, but you're completely crazy. Okay? This is total anathema. And Bretz had a personality, one would call it stubbornness, where he was able to take this. It didn't work all the time. There's some reflection on this in John Sonickson's book, Bretz's Flood, if some of you are familiar with it, because Bretz's daughter remembers that after one particular meeting where Bretz was just excoriated with all kinds of things about why he was wrong, where he was depressed for maybe a week or so afterwards, but then he got mad and went back to trying to defend himself. Well, I can't tell the whole story of that controversy and all the different ways it came about, but it's important background to my relationship with Bretz, because in the 1950s, after he had retired, when he was in his 70s, he went back into the Channel Scabland area and did an incredible study, published nearly 200 pages as a journal article, that went over all the criticisms and gave detailed refutations of those criticisms, plus new discoveries. One of the important new discoveries were what we now call gravel dunes. These features are basically formed the same way that the ripples form that you see on a beach or in a bottom of a stream bed. But these are immense. These particular ones on West Bar are up to 50 feet high and a couple hundred feet in spacing. So they are huge, and look at the number of them. This is a road going across it. Okay, this is actually a pretty unpopulated area, so they're very well preserved. There also are giant gravel bars that the pre-flood river is actually a little tiny thread that goes in between those high points. Everything in that picture was underwater, and the valley was filled with the giant bars that were created by the floodwater. So he had lots of data by the 1950s that came from the Bureau of Reclamation. So this is background to my connection with J. Harlen Bretz. I wasn't there 100 years ago. I know I look kind of old, but it doesn't take me back that long. So that's Bretz when I first started communicating with him. And this is my initial letter, July 9th, 1969. So I was a grad student at the University of Colorado, and I was dabbling in different areas, but I finally hit upon, well, I'm going to study river processes. Boulder, Colorado had a big flood in 1969. I got really interested in floods, and I was studying river mechanics with a professor at Colorado School of Mines who had been on a field trip through the Scablands. And he saw what I wanted to do, and he suggested maybe I'd look into it. So I wrote to Bretz, and I sent him a paper I did. It was kind of a prospectus for a dissertation to look at the quantitative physics of how the Scabland flooding worked. One of the criticisms of Bretz was that it was argued that floods can't do this, that it's physically impossible for them to do some of the kinds of things that Bretz was claiming the floods did. So I was going to evaluate that. I was going to use physical principles and see if they were consistent. And one of the things that I had learned working as a hydrologist for the United States Geological Survey was that you could use evidence of the past flooding. So this is a longitudinal profile along the Scabland Channel, and these little marks are high water levels that were reached by the floodwater. And you can see there's a slope to that, and that's related to the energy expenditure in the water as it's flowing downhill. That energy expenditure there's mechanical relationships. It goes back to Newton's mechanics that allows you to relate that to things that tell you about the magnitude of the flooding, and that can relate to its ability to do erosion and to move sediment. So I told Bretz that was what I was going to do, and he communicated back that he was absolutely delighted, you know, the problem of having hit his head when he was small. So I actually used the material I was putting together to get a National Science Foundation grant. I couldn't apply for it, I was a grad student, but my advisor, Bill Bradley, University of Colorado, he put in the proposal, and we got a whopping $4,565 to do the study of the channel scab land and the mechanics of the flooding. Well, I like this particularly well because the PBS production, Mystery of the Mega Flood, was mentioned. If you see that production, you think they spent $2 million based on 4,560. Well, actually, I did a few things after that, but the basic essence of everything was supported by that. There's some of my field notes. And I communicated with Bretz about this. By the way, this is one of the kinds of things that the people said to Bretz, "You're crazy." That was moved by the flood. Okay? Well, that's probably the biggest boulder, but still, you're not talking about normal river processes. And when you work out the mechanics of this, these are some of the strain power is the rate of energy expenditure, and it is related to bed shear stress and mean flow velocity. So remember, I talked about energy. The energy levels that you get in catastrophic floods are totally different than what you would get in a river. Even you see high energy rivers on television. People are saying, how incredible that is, how much power there is in that river. Nothing. They are minuscule compared to what that is. And the reason is that the energy expenditure goes up with the square of the velocity. It's not just that the water is moving faster. It goes up to astronomical levels. And all that energy goes into the power for erosion and moving sediment and picking sediment up. So one of the things that emerged from my work was it had to do this stuff physically. To claim that the physics wouldn't allow to do it, that was completely wrong. The physics demanded that it do the kinds of things that it did. This is called consistency. And it can be surprising because people can be pretty bullheaded and think that their experience is what tells them how the world works. No, the world works the way it works. Your experience may be limited. The world always has the right answer, not you. So people may think they're brilliant, and they develop some quantum mechanical theory or whatever. It's not their brilliance. It still has to match how the world is. And that's one of the big lessons in science that even a lot of scientists have trouble getting straight. So it was 100 years since Bretz's first paper came out. So my first papers also came out 50 years ago. The one on the left was a publication by the Geological Society of America. It was a little book that was my dissertation. The one on the right was on the erosion mechanics, and it was published in a volume about fluvial geomorphology. So missing, though, is a part of the slide is missing there. When I went to University of Texas, they had a famous geologist who was my predecessor there in teaching geomorphology named J. Hoover Mackin. And Mackin was familiar with the scablands. He died in 1969, which opened up the position that I was able to get at Texas. He said, to understand the scabland, one must throw away the textbook treatments of river work. In other words, you read the textbook and it says, this is how rivers behave. The scabland floods didn't behave that way. You had to go out and discover the way they behaved, and you had to understand that from the signs, the evidence that nature presented. And that's what Bretz did. But he didn't do it quantitatively. He did it looking at the patterns in a qualitative manner, and so my contribution was not really the discovery, but actually looking at how that discovery made physical sense. But I had some other ideas about it, particularly in terms of the erosion. So these are some of the erosion features. This is in the Dry Falls Cataract Complex. These are incredible deep pothole kinds of phenomenon. How you cut these things into rock is pretty remarkable. It has to do with the structure of the basalts. And there's a series of diagrams on how those evolved. This was kind of stuff that I was communicating to Bretz. So that came out in 1973. So the combination of the discovery of the giant current ripples, my work on showing that the scabland flooding made quantitative sense, led to a attempt to get Bretz to receive the highest award of the Geological Society of America. It's called the Penrose Medal, and it's like scientific awards, which are kind of a weird business. The science should be the reward in itself, but they insist on giving these, medals and things. It's made of gold, and it's actually a problem because they have to make these gold medals every year, and it's kind of expensive now. But the guy who, Penrose, he left them quite a lot of money. Anyway, there was an attempt to get the medal. They put together a committee, and the committee, this is the letter that was sent to the head of the award committee by the members of the committee that was put together to sort of convince them that Bretz deserved the award. This was in 1974. So it went forward, but it got killed in the process because they couldn't find Bretz's records. At this point, he was in his later 80s. Actually, he was in his early 90s. I met him when he was in his 80s. So he was in his mid-90s. And they didn't have his records anymore. They had kind of presumed that they weren't relevant anymore. And here he was being recommended for an award, and they didn't have record that he was a member of the society or anything like that. Now, that was what GSA said. Bretz, he assumed that it was because he was having a feud with the director of the society, because Bretz had actually written a scathing critique of that geologist before he became executive director of the GSA, when he was head of the Illinois Geological Survey. Bretz always thought the guy, pulled it out of the file and misplaced it. Anyway, Bretz didn't get the award. But something else happened in the early 70s. There was a spacecraft. Here's one of the big surprises in science, called Mariner 9. And Mariner 9, 50 years ago, took images of the planet Mars, and when I saw these, I was at the University of Texas at Austin, and Russ Bunker here was one of my early students. I was teaching things like, geology for engineers, and environmental geology, and geological hazards. I was an environmental geologist. That's what they hired me to do. As soon as I saw these pictures from Mars, I knew they were cataclysmic flood trials. So I became a planetary geologist, which wasn't what they are. Yeah, fortunately I got tenure, so you know how that works. But I published on this. I wasn't even a member of the team. I sort of found my way into getting some of the data. And we published a paper on this just about 50 years ago. We did the work 50 years ago. The paper came out in 1974. And these features called outflow channels were described with all the kinds of large-scale stuff. We talked about the scabland, how big it is. These are immensely larger than those. These are the biggest channels we know created by floodwater in the universe so far. Okay? I say so far because just wait, there will be more. What do I mean by how big they are? This is a paper I did about 20 years ago, but it compares with an exaggerated vertical scale some large channels that were impacted by large-scale catastrophic floods. Now, some of these are valleys, like the Mississippi, and this is the magnitude of the flood, 3 times 10 to the 4. That's 10 to the 4 is 10,000 times 3 is 30,000 cubic meters per second. That is a very large flood of the Mississippi River. So the Amazon River's biggest floods are about 10 times as big, about 300,000 cubic meters per second. Missoula floods were much larger, as much as 20 times 10 to the 7th, which is 20 million cubic meters per second. And these cataclysmic floods were bigger. Bretz didn't know about these. Well, the Mars ones, Aries, Valles, Kasai, he did know about those. But he didn't know the Strait of Gibraltar was created by a catastrophic flood. The Strait of Gibraltar is pretty big. And that flood was about 60 million cubic meters per second. It happened 6 million years ago, and it was the entire Atlantic Ocean spilling into the then dry Mediterranean Sea. Okay? Really big cataclysmic event. This one, that's the Strait of Dover. The separation of England from the continent, it wasn't Brexit. It was catastrophic flooding. And it happened, not the last ice age, but an earlier one. Because Britain, the island, was connected to France. The chalk cliffs extended all the way across. And the North Sea was a vast freshwater lake during glaciation because it was bounded by ice on the northern end. It filled up and spilled over that divide, created what the English call the English Channel. The French don't call it that. So the big channels on Mars, this is the whole half the planet. And the high topography is in red, the low topography is in blue. Here's a zone of cataclysmic flooding. It's 400 kilometers across here. Okay? These are big channels. They go right into that northern basin on Mars. The channels have impact craters on them, so they're very old. Those outflow channels are generally about 3 billion years old. So there's a big difference there relative to Earth. So that's a time frame, 1970s. In the 1970s is when I was having a lot of communication with J. Harlen Bretz. Initially, because of my dissertation, the research that came about, and also because these things were discovered on Mars, and Bretz was completely delighted about that. He started out thinking he'd be an astronomer. So here's some of the things Bretz was sending to me in his handwriting. You can't really see these, but he sent me a lot of stuff that was related to his experiences in the field. The one on the left is about all the car trouble he had with various vehicles. The one on the right tonight is about the field work in the 1950s, where he went out in the field with a bunch of people, and he had fantastic experiences with that. So I have a lot of that kind of material. But more relevant, I think, is the story that continues to tie him to his research. Now, because the scabland features were considered to be something similar to what had occurred on Mars, it became important for geologists to see the scablands and compare the features they saw there to the features on Mars. This became critical for missions. You probably remember the Viking mission, which was supposed to land on Mars in 1976, okay, an anniversary year. And it was supposed to land on July 4th, okay? It was going to be a Saturday. The spacecraft was going to land in a catastrophic flood channel and called it near what's called the Crissy Basin, and the channel is called Magavalis. And they took radar pictures of the landing site and found it was too rough. The spacecraft, if it hit a big boulder, would tilt over and wouldn't be able to operate properly. So they had to move it to a smoother part of the channeled areas. But they were studying the features on the ground to relate them to features in the scabland to see how the roughness of the terrain was. For a later mission called the Pathfinder, I was actually out in the field with the Jet Propulsion Lab engineers, because if you remember, Pathfinder had this little robot, looked kind of like a toy compared to the big ones they have now, and it had to drive around the terrain. It had instruments to make measurements. It was called Sojourner, was the name of the robot, and Sojourner they had a full mock-up of it. They took to the scablands in a boulder field area so they could drive around and see how it operated. I was very fortunate that I was president of the Geological Society of America in 1998, after Sojourner had landed on Mars and done her exploration. I was able to give a honorary fellowship to Sojourner as president of the Geological Society of America. So it's the only robot geologist that has ever received that honor. But I communicated to Bretz about some of the field work. That title at the left is a field trip that I ran in the Channel Scabland in 1977 for the Geological Society of America. And at the end of the trip, there were 70 people on it, and they all wrote notes to Bretz about how they were totally convinced he was right, and they could never believe anybody ever doubted him. And I sent those to Bretz, and that's the note I have with that. There was one of Bretz's former students on that trip, and I was in it was a bus trip, it's 70 people, and I was in the seat behind the driver. And the seat across from me was a very famous geologist and his wife. And he looked at me the whole time because he didn't want me to do any injustice to J. Harlen Bretz on the field trip. And in the end, he said, I didn't do any injustice. Imagine him later. He's a very famous guy. He plays a role in the story. So here's a reply that Bretz sent to me. I did mention that his real name was Harley, and he got it J. Harlen. He made that up. The story is that he turned in his dissertation to his advisor, a professor named Salisbury, and on his dissertation he signed it J. Harlen Bretz, J with no period after it. The first name is just the letter J. And supposedly Salisbury looked at it and said, what is this? that's not your name. And Bretz answered, that name doesn't sound like a real scientist. I've got to put a name on here where I sound like an authentic scientist. and Salisbury apparently said, okay, well, you better not let anybody put a period after that J, because that's what they're going to do. They're going to assume that it's just like J. Hoover Mackin, whose name actually was a J period, because he had some peculiar first name he didn't want it to be used, and they used the name Hoover all the time. Okay, well, Bretz fought battles with editors of journals and the like for decades over that J. Okay, so then he wrote back to me about the material that I had sent him, and I wrote more to him about the field trip and the nature of the stops, because he was very curious about the stops we went to and what they looked like, because he hadn't been there for very long. But I also had told him in that letter that I was working on another field trip with a much more extensive guide. And this one is out of print now, but it was actually supported very handsomely by NASA to be a guidebook to help with their planetary missions. So it was called the Challenge Scabland, and the guidebook has a 2-page introduction that was the last formal paper that J. Harlen Bretz wrote, because he wrote the introduction for the guidebook. And there's a whole bunch of papers about features in this Challenge Scabland. This came out in 1978. That got a lot of attention. This is a letter I got from Stephen J. Gould, who's a professor at Harvard University. Steve had always been kind of a fan of Bretz, because Steve had this view of evolution that he called punctuated equilibrium, where catastrophes in past Earth history caused extinctions, and those extinctions were very important in the evolutionary history of organisms. So you will find in one of his many books called The Panda's Thumb, there's a whole chapter on the controversy in Scabland, J. Harlen Bretz, which he thanks me for in providing information about that, and this is a note he sent me in regard to giving him a copy of the book that I showed previously. It's also about this time that I was given the charge by the Geological Society of America division called Quaternary Geology and Geomorphology to once again put in a Penrose Medal nomination for J. Harlen Bretz. And so I arranged to see him. I actually went twice, but this was one where I went on October 27th, 1978. The picture at the beginning was one that was taken that. And so I went to Homewood, Illinois, and here's the other picture that Rhoda took. Doc liked this picture. He thought it looked more serious and scientific than the other one. I didn't really care, but I had hair. Okay, so there was a saga with the Penrose Medal. We put in the nomination, and the GSA fouled it up. They gave the wrong date. We didn't get in because we were assuming one date that they had told us, and then they said they had changed the date, and it didn't go through. There was a lot of people very upset, and GSA sent me apologetic letters and all kinds of things. So they put us in for the third time. And the third time it was successful. Now, this nomination package was amazing because we got letters from famous geologists. This guy, he had the most impressive letter named M. King Hubbard. M. King Hubbard was a fantastic geophysicist. He developed theoretical expressions for groundwater flow. He worked on amazing things relative to petroleum geology. He had one of the classic papers in structural geology on overthrust faulting. He just was all over in geological sort of excellence. M. King Hubbard took J. Harlen Bretz's field course, and he had 3 principles that he later used for his entire career. He learned them from J. Harlen Bretz in the field because the technique shocked him. I mean, he was the kind of guy that devoured information, was exceedingly well prepared. So he went to Bretz before the field. He was an undergraduate. He took the course as an undergraduate, and then he took the graduate version of it. So he took both versions. So he went and said, well, what should I read up about this? And Bretz said, absolutely nothing. Absolutely. You go in and you find out for yourself. And so Bretz would not, he wouldn't just throw them out there. If they had questions, they could come and talk to him. He wasn't going to tell them the answer, but he was going to sort of, give hints and things like that. But they had to go out and figure it for themselves. And after that, they could, if they wanted extra credit in the course, write a report on the other literature on related to what they had seen. And Hubbard was completely shocked. All these famous people had worked in this area. It's called the Baraboo Lake area of Wisconsin. And they were wrong. That they had missed things. And after that, he realized that there is no such thing as an authority in science. Nature is the authority. You have to be humble in regard to what nature presents to you. And in the early parts, the second principle he had in any study, you have to figure the literature is going to be somewhat wrong. It's all wrong in some way, because it's never exact. We're not perfect, and our relationship to nature isn't that perfect. We try very hard, but there's still things to be found out. And you have to do what he found out. It's not about reading all the conventional literature on the subject. It's actually study the phenomenon first. It's all right to bring ideas into the field, but don't think the answers you read from other people, you don't want to be too confused by those, because you want to discover things that they didn't see. And you can be confused if you get too much into what the other people saw. He learned that from J. Harlen Bretz. Well, the third, partly helped by that letter, and I was in charge of putting this all together, but it was really the fact that Bretz had impressed so many people that he was able to get the Penrose Medal. This is from the GSA's announcements cut off at the top of their awards. And the second highest level is called the Day Medal. It's for quantification, but the Penrose Medal is for pure geology. And Bretz received that, and he was in his, I think he was in 96 or 97. He received it just before he died. He wasn't able to go to the medal ceremony. I was asked, Bretz wondered about whether I could do the citation, but the obvious person, for a couple of reasons, to do it was King Hubbard. And so Hubbard did it. And I was in Australia anyway. I had a Fulbright Award. So I was in Australia when this happened. It was the 1979 GSA meeting. And Rhoda's wife read Bretz's statement. By the way, this is him with the medal. You can see it. And this is also his New York Times obituary from 1981. He got the medal at the end of 1979. So it was a little over a year after he got it that he died. But the citation read that at the end he said, well, he talked about how he had sort of showed geology that uniformitarianism wasn't perfect, there could be exceptions, and he described an exception. He said that he had a big regret, though, in getting the medal at this time. And it was because he said all of his enemies, those that disagreed with him, were dead. And he added, I can't gloat over them. Unique medal acceptance speech. He wasn't there in person, his daughter, but, you know. Well, the saga went on. Shortly, not too long, I think around 1982, I came out with 2 books. One was sort of developing the history of the catastrophic flooding, and then another was on the features that had been discovered in the early 70s on Mars, and better imagery came about later on. So I did a book on the channels of Mars. Tremendous amounts of things have been done in relationship to. So we've learned a lot more about Mars. Those big channels, you saw this one here, Kasai Balas, in an earlier picture. They fed into the northern plains. It turns out there was an incredible, huge ocean on the northern plains at that time. Mars was a very different place 3.5 billion years ago than today. It's an exceedingly dry, cold desert today, but it was a different kind of planet. That ocean has been a controversy for decades, but its evidence just gets stronger all the time. There was a Chinese lander mission, rover on Mars, called the Zhurong rover. It landed in the ocean basin, and a paper was published just several months ago on the sedimentary rocks that were thrown out of the basin by impact craters, showing that it was a water body. The other thing that relates to this, and I'm getting into current research, because there was this water body there, there were impacts into it because this early period on Mars had a lot greater impact cratering, and giant tsunamis were created in that water body that impacted the margins of the ocean. These tsunami phenomena were much greater than anything we have on the Earth, and they had the kind of intensity of catastrophic floods. Another thing that has happened since the 80s is we have discovered all over the world areas where cataclysmic floods were being associated with the last ice age. So we even now have a name for them, megaflood, where the level of discharge is the same unit that is used to measure ocean currents. So these catastrophic floods are different than ocean currents because ocean currents move very slowly and allow large masses of water to stream across through the ocean, like the Gulf Stream is an example. But these floods are high energy. They last relatively short time periods, but they have incredible power. And all those red areas are megaflood ones. So here's the English Channel. These ones, all over North America. The Missoula flood one is this one. Most of its effects were on the floor of the Pacific Ocean. 2,000 kilometers out into the Pacific Ocean, the effects of that flood were created. So the part on the land is relatively small. This makes them even more similar to the Mars floods. This is a paper that I did showing the patterns of them related to the big ice sheets. This is a view down from the North Pole. The flood areas are, well, the lakes that form, like Lake Missoula, which is that little thing there just to the left of the 5. That's Lake Missoula. There were much bigger lakes. This was one of the biggest, Lake Mansi in the West Siberian Basin. The predecessor of the Caspian Sea was a giant lake, twice the size of the Caspian. The Black Sea was a freshwater lake during the last ice age. It's now ocean. And its connection to the Mediterranean was created by catastrophic flooding, called the Bosphorus and the Dardanelles. Those are catastrophic flood channels. So these things are all over. And one of Bretz's mistakes, one he's happy about, is he would try to argue at one point that uniformitarian didn't have to worry because this scabland thing was unique and it was the only place where it happened. Turns out it's a general phenomenon that people had ignored because they had this theory that catastrophic floods didn't happen. They weren't supposed to happen. Don't tell nature it's not supposed to do something. They're going to get in trouble. Okay, this just happened about a year ago at my university. A minor planet. They're called asteroids in some. There's a whole lot of these things, and I'm in a department of planetary sciences, so I've got all these people look through telescopes and discover objects. And so one of the fellows who knew about the Bretz story has named a minor planet Bretz. So the guy who wasn't going to be an astronomer now got his name on a minor planet.
Right.
So, yeah, so I continued to work in Channel Scabland. This was September last year. I was doing a field trip for UCLA grad students, kind of like Bretz, and introducing them to the scablands, which we now can use Landsat images like the one on the left there. And so it's been a great privilege doing this. I've enjoyed it quite a lot. I sort of emphasized my personal story this time. There's a whole lot of the science that I didn't talk about. I alluded to it because it has a background. And this is maybe the second or third time I've talked to this group in this room. I don't know if any of you have been to earlier ones, because some of them were years ago, and it was on different topics. I talked to maybe 7 or 8 of the Ice Age Floods Institute groups, all the way from Spokane to the Puget Globe group in Seattle, and, pretty much all over. Talked mostly to the Wenatchee Iranics. I guess they felt I was appropriate for the... They seemed to like having me. Anyway, thank you for the opportunity to talk to you folks. And if you don't have any questions about this, you weren't paying attention.
You're going to be with us again next year on August 15th. That's the third Thursday of the month of August in 2024. So I have it right on the calendar. Oh, that was wonderful. Thank you. Do you have questions? Yes.
Yes. Yeah. Sure. Over here.
So when was the first aerial photography done, and that he or others were able to utilize, and what did it make any differences in conclusions or facts or anything?
The first aerial photography that appears in his papers came out in the early 1930s. And maybe some aerial photography was being done in the 20s, but he didn't make use of it. He did a monograph with the I think it's called the American Geographic Society, kind of a stuffy organization. Bretz didn't like stuffy organizations, but anyway, they did a very nice job publishing it, and it has lots of aerial photographs, including stereo aerial photographs in it. So he recognized the importance of aerial photography as soon as it was widely available. And his later papers, like the 56 paper that I mentioned, is filled with aerial photographs. That became very important. Well, now that we have satellite pictures, you've got Google Earth, it's a different world in regard to that. And the scale differences are now, you can do it with Google Earth, do things that weren't possible in Bretz's day. But he could envision all of that. Obviously, he had to make the maps that he did. Yes?
You have a wonderful story to tell. I was wondering if you thought about putting this into writing, so history will have that, the history of you, the Bretz, and primarily Bretz.
Yeah, I have done it in academic ways. I did an extended paper on the Spokane flood controversy. Bretz initially called the floods the Spokane floods. And that was the controversy in the 1920s. So I have written about that. There are these academic areas like that deal with history and philosophy or science, and I'm very much into that. But I am currently writing some books that might be a little more available to the public. And so part of what I have talked about here is probably going to go into a book that deals with outrageous geological hypotheses, because Bretz is the type example for that. And so some of what I'm talking about here is really intended to be for a book that is not going to be sensationalist. It's going to be scientific, but at the level of a science magazine for the public, like the Smithsonian, something like that. I'm still working on what level to pitch it, because I spent nearly all my career talking to other geologists and not so much the public. But I do have a lot of things that will be great interest in.
I have a question for Charlie. Is this recorded, this presentation?
Well, I've been doing that tonight.
Will it be online then?
I don't know yet. We're talking about that also. Need to get the doctor his permission.
Yeah. Okay. You're having.
Thank you
I have over here.
Thank you for coming and sharing your personal experience, and also the way in which you forwarded this interesting work. I had a question. One of your last slides was about megafloods in other areas of the world. Was Bretz pretty much a spearhead with his ideas and fascination with the phenomena in eastern Washington? Or was there other research going on which might have paralleled his work or contributed to it?
There were places where things involving catastrophic flooding were thought about. Some of it not scientifically. One that I encountered in my work was in Russia. It was the Soviet Union when I went there. It became Russia. But the Soviet Union's science had been kind of isolated from the science in the Western countries. The Soviet Union had an incredible large geology establishment, probably the largest in the world. The metallic wealth of the Soviet Union was of incredible importance to Stalin. Okay? He wanted to take over the world. Well, he needed steel, he needed iron, he needed minerals. He didn't know how to find them. He needed geologists. So geology was able to have a kind of freedom that wasn't allowed, and they had a status to do things. So there were a lot of geological ideas spinning around. And they had megaflood evidence. They had megaflood evidence in, extreme. And they had their own controversies about it. It's an unexplored story to some degree, but I got involved in it when I was invited to go to Siberia. It was 1991. And it's clear that the controversy had been going on for some time before that. And I was with one professor who was on the flood side, but there were others. And one of the things that happened to us was there was a senior guy at his university who was kind of in charge of the secrecy stuff, and he impounded all the topographic maps, so we couldn't take them in the field with us. Not because he was worried about I was going to give them the CIA or anything. He just didn't want me to know about the stuff his colleague was doing, arguing that it was about catastrophic flooding. There's a lot of stories. But you had a question.
I had spaced on the name of this geologist until instantly, but did Bretz ever talk to you about the geologist who knew where the water came from?
Yes, that was Joseph Thomas Pardee, and Bretz knew Pardee very well. Pardee knew Bretz well. You couldn't have two people with totally opposite personalities, and J.T. Pardee and J. Harlen Bretz. J.T. Pardee worked for the United States Geological Survey. He had a boss named W.H. Alden, who was a vehement critic of Bretz, and that was his boss. Pardee, Bretz's first field season was in summer of 1922. That's his first scabland season. That's when his team came out to Spokane. They took the train out in 1922. Pardee had been in the field there that summer before Bretz. And from sort of indirect evidence of things that Pardee had told to high school teachers that were helpful in that area for people getting set up in the field, Pardee was entertaining the idea that catastrophic flooding was created in John Scabland. In other words, he was pursuing that idea at the same time Bretz was. There's no way he could publish something. He couldn't do anything because of his blog. That's a whole other story. Yeah.
Talk about it.
Okay, yeah.
Were the missing papers ever rediscovered when he finally received his gold medal?
The first
time.
Oh,
the
yes.
papers were missing.
They reconstructed it. I don't know the details of whether they found the actual papers, but they had lots of evidence that he was a member. He published in the journal. I mean, there wasn't any time to deal with it. That was the first time that it went forward, and it was, they wanted to do it again, but they had other candidates. And by the time they got around so that was the 74 attempt. By the time they got to, it's either 77 or 78, which was the first time I put together the package. It was only a few years afterwards. And they were already, kind of miffed about what happened that time. And then they made a mistake the second time. But eventually, he lived long enough to get it. Yes.
I was just reading the A Wonderful Life by Stephen Jay Gould and talking about the Burgess Shale, how important that is for paleontology. I was wondering, is the Scablands to geology what Burgess Shale is to paleontology, in the sense that it's something unique about the geology there that preserved it, made it the best canvas for depicting megafloods?
Well, there are circumstances in almost any geological situation that make them somewhat unique. The Scablands, the catastrophic floods were able to do things with their topography in large part because of the characteristic of the basalt bedrock. That bedrock responded to the flood flows in a very different way than, say, a granite or a metamorphic rock would respond to the flood flows. And we now have other places around the world where that happened. The big floods in Siberia, they responded, you don't see the kind of scabland topography. There are features in glacial Lake Missoula, which is Precambrian sandstones and other metamorphic rocks. They have flood features that look like the ones in Siberia, and they don't have basalt. So that is an important part of it. As you know about basalt and how it gets the columnar joining and all of that. That relates to the flood flows in a particularly special way. And it's still not a completely solved scientific problem. Yeah. In the back.
Have you, or has there been, or will you archive any of Bretz's field books?
They are archived.
They are?
Yes,
If
the
ever-
University of Chicago has all this materials.
Well, that's good. In
And
your ephemeral,
they're well curated. If you go to their special collections online, you can get the whole catalog of this materials.
Wonderful.
And they're being looked at. I know Nick Zentner has been perusing them in great detail. I looked at them years ago
I
for
hope-
more specific purposes, but
I hope your work is also going to be, certainly the university there in Arizona ought to be pretty active in helping you archive yours.
that's a scary thought. My stuff is such a mess. And these days, the archiving, all this material was written on paper. I mean, this stuff is just disappearing into the void of the
That's exactly why it should be
cyber
archived.
world. And we're all worried Chat GPT is going to just do it all for us anyway. Actually, I'm interested in that, and I don't think computers will replace us. They will replace the uninteresting things we do.
Yeah.
They're never going to replace the really interesting. There's reasons for that, but that's another story.
I have a question for you. There was my neighbor just came back from a cruise to Alaska, and he was following this group and so forth. He said, well, there was a mini mega flood a couple weeks ago in Juneau.
Yes, I heard.
Because the ice dam broke
Yeah.
right there. And
Yeah.
the river rose like 10 feet, just like almost immediately.
Well, you're getting a lot of ice dam lakes because of the retreated glaciers, and they're creating situations where they have ice dam lakes. One reason why my PhD advisor at the University of Colorado was interested in my project, he and another fluvial guy were wanting to see what glacial lake bursts did when the ice failed, and there was a lake near Anchorage that was being released every year. It would form every year, and then it would burst out, and then the lake would form again in the winter when the glacier advanced and resealed the lake. So they've been doing this for decades. So they got an NSF grant to go up there. That was the first year it didn't fail. So my thesis intrigued him for that prospect. He was very helpful. And he got me $4,000. Yeah, it's pretty fun.
Not a question, but there is I think it's a website, I see it on Apple News called High Rise.
Yeah, Harlen, the
R-I-S-E.
guy at my university is the head of the whole.
Oh, is it? Yeah.
One of my
Well, yes.
PhD students is one of the team members.
Oh, yeah. It's just got great,
Yeah.
satellite
Yeah.
views of the Martian surface.
Yeah.
It's
Yeah,
detailed.
but it's mostly focused on the fine scale. The flood channels are huge, so when you use high-rise images, you're looking at little details. You could look at the boulders, with that, but no, high-rise is fantastic. It's made a lot of discoveries about Mars. Yes, it
at parties, field work, a lot of his writing, and they pulled them out of boxes. And I don't know if it's now a permanent display, but since I hung around and was kind of a pest, they let me put gloves on and read some of his work.
Is this at Butte?
No, this was in the city, you know, it has the strand lines.
Oh,
So,
this
yeah,
Missoula.
the city, yeah.
Missoula, right, yeah, no, but, yeah, Missoula has a lot of stuff. The whole mountainside is a sort of trail for, it's right, the campus is right below the strand lines of the place where Missoula. I was just there in December with a Japanese film crew. They did a 90-minute program it's called NHK, it's their equivalent of our public television, and they have a series called Great Nature. And it's kind of this befuddled Japanese guy that comes and visits geologists in different places around the world. And so this guy does a thing talking to me about the scablands, and we sort of are transported to all these different places. And look at the features that are associated with catastrophic flooding. It's in Japanese. I speak in English, but they subtitled it in Japanese. And it was in Tokyo. It played there at Christmas, just last Christmas. But it's not. I don't think it's available online, but it appears online. It'll be called Great Nature. It'll be the episode on the northwestern U.S. It has a part on the Columbia River basalts, and then it's got a part on the Scabland flooding. It's pretty well done. They did some animation for it, but so they try to tell the story, but in Japanese. So.
You want me to explain what, if any of you noticed when you were coming in, there's some big boulders outside along that way and around that. They didn't come easily for us, but they are appropriate. One of the contractors in the city moved three of them, to Fields Bridge Park over in Willamette area. And I found out about him. I was a former city manager, and I grew up in Tualatin, so everything is pretty close to me. I found out that they had found those boulders over in Willamette, right up here by the country club in Tualatin. And nobody had ever told me about that. So that was my first, by that time I was president of the Historical Society, and I asked them if they would, I asked the contractor, Brian Clopton, if he would then get us some of those rocks. And I got a call from a farmer in Gaston who was going to blow up the rocks in his farm if someone didn't come and get them. And he said he didn't want them, they were in the way, and they would just blow them up. And these were Ice Age flood rocks that had come clear out up the Tualatin River and then Gaston. So I arranged with that same contractor, Brian Clopton, and said, okay, I'll forgive you if you'll take your big trucks and all of your equipment out to Gaston and get those rocks. We've been friends ever since. He's also a member of the IAFI and wanted to participate. But those big rocks took huge equipment to move them all the way from that area and to take them off the truck. But I feel like we're really lucky, and that's sort of cemented our friendship with the IAFI, and we're going to try to build an interpretive center for these ancient mastodon things and all the rocks and all the bones and that as a result of their coming to Tualatin.
Thank you. I'm proud to say that Yvonne is a member of our board, and it's wonderful. So we're doing great work. What is that? Yay! Okay. That was an absolutely marvelous presentation. And I can't tell you how much fun I had typing up the constant contact from your bio. It was just wonderful going down through all the parts and every single word that you gave me is in there. And it was wonderful. Thank you. What a wonderful talk tonight. And we have a gift for you. And this is something that the Snare's been doing. Now, we happen to have another flavor. So we have raspberry and we have strawberry. I'd like to give you as a thank you tonight.
Oh, thank you very much.
Yes, absolutely. Very active. It's a real pleasure. And thank you so much. What a wonderful evening you had. This is a marvelous group tonight. And I assure you, I'm going to take care of getting that connection. I'm going to take a photograph of it. And make sure we're going to have that connection. That won't happen again.
Well, Apple in particular keeps changing.
So we have to thank John for the use of this computer and save the day because we have to have this one for him. Yes.
I think that's it.
I want to thank you, sir, for saving on this talent so we can see this marvelous presentation. We just didn't dig deep enough in terms of equipment capabilities, and my lesson is learned. So we're gonna fix that. Thank you so much.
Just one comment.
Sure.
As you know, Charles has just become our new president of the IAFI after Rick moved to Georgia.
This chapter.
Of this chapter, the Lower Columbia River chapter. And I am proud to say that he has responsibility for another very big trophy, the Portlandia, what do you call it?
Well, the installation of the Portlandia statue.
He's responsible for that. And
Which is 1/3 the size of the Statue of Liberty in terms of height. It's 38 feet, Liberty is 150.
And so I wanted you to know that we have a pretty good president right now and welcome your participation in the future too.
Thank you very much. It's a pleasure. I really enjoyed this, and I'm actually two of us were founders of this on my birthday before, and that was Mark Buser and myself. It's nice to be president.